So I wanted to give you a little background for the FRQ, and I'm going to have to do a couple of recordings on this. But to get you started, if we're looking at the sparse array FRQ, they tell us a sparse array is one that has lots of zeros. So to save on memory, we're only going to store the non-zero values, and we'll know if we don't have a value given a certain row column coordinate that means it's a zero. Now they've drawn this as a two-dimensional array structure. This is one thing that's a little tricky here. They're drawing that as a 2D array to help you visualize it. But in memory, this is not a two-dimensional array. We are not declaring a 2D array. As a matter of fact, we're using something called a list, which is related to array list, and we know that an array list cannot be two-dimensional. So the drawing of this as a 2D array is for you to help visualize it as you're reading the problem. It is not a traditional 2D array stored in memory. And so they tell us we're going to use this sparse array object. They give us some of the class information on that we're going to call it sparse, and that we're going to have various instance variables that go along with it. The instance variables primarily being the row, the column, and the value that's stored in that position. Alright, so the items and entries are in no particular order, and they show you one particular ordering below. Alright, so when you think about what we're going to talk about in a minute, which is a list. When you think about a list in memory, it looks more like this. It's more of a horizontal approach. This is not a two-dimensional structure here, this entities list. It's kind of a linear thing, and that's sort of how it is in memory. So don't get confused between the fact that they're giving you a 2D array visually, and then they're talking about an array list and a list, which are not two-dimensional. So entries is more like what you would see in memory. And notice we're not really having necessarily an array structure. What we've got are different objects within this sparse array, and they have different instance variables, row, column, and value. Those are just instance variables. I could have called them X, Y value. I could have called them A, B value. It's easier to conceptualize these as row and column coordinates, but they are just straightforward integer instance variables. That's all these are. So an entry is basically just an object, just an element that has three instance variables, row, column, and value. We conceptualize it to make it easier on ourselves as a 2D array. All right, and they're telling us that we have 6 rows, 5 columns, again to help us visualize it, and here are the values. All right, so we're going to write the sparse array method method get value at. The method returns the value of the sparse array element given a certain row and column. So we're going to have two parameters coming in, row and column, and we're going to get the value back and send it back. If there's a value present, so they give us a 1 and a 4, and we can see that the value is 4 for that, we send that back. If they give us, say, a 1 and a 3, there is nothing in row 1, column 3. Oh, no, of course I picked something where there is, I guess. Say they gave us 0, row 0, column 1. There's nothing in there. So notice we don't have an entry for it in the list. There's nothing there because it is supposed to be a 0, and we're not going to store zeros to save memory. So if we don't have an entry corresponding to those two coordinates, that means it's a 0. Okay, and so they're telling you to name it get value at. That it's going to return an int, and it's going to take 2 ints in. And the precondition basically tells you that the row is going to either be 0 or it's going to be 1 less than the number of rows. The column is going to be between 0 and it's going to be up to 1 less than the number of columns. So all they're telling you here is you can expect to get good data. You don't have to worry about somebody entering a -5 for a row or somebody entering the number 1,000,000 for a column. That the values coming in are going to be within the range of 6 and 5, so you're going to get back 5, 5 and 4, because we're always one less because of the zero offset, and we're never going to get a number less than 0. So you don't have to worry about coding for bad data. That's what the precondition is telling you. So if you want to write this method, and I should have started here with the sparse array. Again, summing up, everything has a 0 unless it's specifically coded with a value. And so here is our sparse array entry. Notice our instance variables, row and column, and value. Okay, and then here's our constructor where we basically send it a row, a column, and a value. We set our instance variables. Here we have our typical get methods to get the value in a row or a column. We can get the value that's in a row or column. We can also return the row index of an element. So we've got some getters here. Then we have the actual sparse array class itself, okay? And so we have this class is going to allow us to create a list, we'll talk about that in a second, of these, okay? So I'm going to have multiple sparse array entry objects in the sparse array object, all right? Okay, so here's one of the things I wanted to talk about really quickly, and I probably won't do the solution in this, but I'll get you started here. So you've probably not seen this before, list of type sparse array entry, and it's named entries. So we're saying set up a collection that's going to hold multiple sparse array entries, multiple row column value sets, which as you saw in the diagram is exactly what that looks like. Now, I want to talk a minute about what a list is. We're going to get to this more in a little bit down the road. So in order to understand what a list is, you have to understand a little bit about the idea of inheritance, meaning I can create a generic class and then that can have a child that inherits methods and instance variables from it, and then that child can have a child of its own that inherits from the middle level. And we're going to see inheritance coming up really shortly. But it's just a way to help you reduce the amount of code you write. So for example, one high-level parent might be person, and the instance variables in person might be first name, last name, date of birth, social security number. I would have getters for each of those. Get social security, get birthday, set social security number. And I would have all of the methods that I would need for a generic person in there. And then a child of person might be student. Student can use and leverage off of all the getters and setters and instance variables and even the constructor in parent. But then in student I can put specific things like calc GPA, get class rank, etc. And then I could have another child of person called teacher, and that might have a salary that goes with it. So you can see where there's this idea of drawing a family tree. If I were to draw that, person would be at the top and I would have two arrows coming off. One would go to student, one would go to teacher. Well, the Java language itself actually has this idea of inheritance. So at the highest level we have a parent called collection, and that's just a bunch of objects. It could be all the CDs you own, all the MP3s you own, all the toys in your younger brother's toy box. It's just a collection of objects, and it's in the java.util library. Now there are different types of lists. Some require to be ordered, some are not. Some allow duplicates, some do not. So we have linked list and set and all these other things going on. So the idea is that collection is the generic higher level, and it's just a way to keep a bunch of objects grouped together. Okay? Collections are memory and runtime efficient. They can grow and shrink. What does that sound like? You should be thinking array list. And they have iterators, which again we're going to get to a little bit down the road, but they have their own ways other than for loops that you can go through them. You can still use a for loop, but they also have their own way of looping. Then collection has a child, and that child is named list. So list can use all the methods, etc., that are in collection, and then it has its own specific ones. And I think list is really an interface. We're going to see that coming up really shortly. For now, that doesn't matter to you. A list is ordered, but it can contain duplicates, and that is what they've used here when we see private list. So they're saying create a list, a collection that allows duplicates. It'll be ordered of these sparse array elements, and that's all that is. And it has various methods for adding, getting the size, getting the values, setting values, and so on. Now, array list is a child of list, so this should kind of make sense. Array list can grow and shrink. It has similar types of methods, and so on. So when we want to declare a list, in this instance, they're setting up a list to hold multiple sparse array entries, multiple row column value objects, okay? And then in order to really finish the creation of that entries object, to really get it set up, you have to finish the constructor, and notice it's private list, the type sparse array entry, and then we do new array list, and again it's the type, whether we were using string or integer wrapper or sparse array entries, that's what goes in the brackets. So when you do a list, you can do private list equals new array list. So we're setting up an array list in memory that is this generic list. And I don't quite know how else to explain that. It's just you can set up an array list specifically as an array list, but since array list is a child of list, you can set up a list that is an array list. You can do it this way as well. So I didn't want you to get confused on that, and that's a new little wrinkle in this. So you can see how we're kind of seeing it visually as a 2D array, but it's really not. It's just a linear collection, and we're going to process it like it's an array list, but we're using this kind of weird syntax to set it up. And we'll see more on this coming up very shortly on lists in one of the chapters in the textbook. And so here they're just giving you your typical methods, okay? So, and I'll leave you to look at that. So the first question is, how do we do a get value at? And so what we're going to do for that is, and this is a pretty standard answer from the College Board, we're going to pass in the row and the column. We're going to iterate or loop over using a enhanced for loop. You could do it with a regular for loop. We're going to use an enhanced for loop just to practice with it. And we're going to iterate or loop over every entry. And again, this isn't really a true 2D array, right? We're visualizing it that way, but it's not that. It's really linear, so we can't really do your typical, entry bracket 1 bracket bracket 2 bracket and check the value, or entry bracket row bracket bracket col bracket. We can't do that. So what we have to do instead is leverage off of that get row method and say, well, am I on the right row and column? Right? And again, we have some totally missing items from this thing because those are the 0 ones that we didn't bother to fill in. So we have to go more this route where we say, go through what you have in the collection, in the array list, and check the row and column values. And if I find an exact match for row whatever, column whatever, if that's legitimately there, then give me back the value at that location. Otherwise, I'm going to return a 0 because that row and column are not in the collection explicitly, and that means it's a 0 element. So take some time and kind of wrap your mind around that. For those who are going on to the second part with the remove column, where you have to take a column out and then you have to shift everything over, I guess, to the left to accommodate that. We're going to use, in this case, with lists and collections, we'll find out you have to be careful if you're removing columns. You have to use either the traditional you really have to use a traditional for loop to iterate over it if you're doing a remove, not an enhanced for loop. So we're going to use a typical count from the end type for loop here, and we're going to check the column and decide if we need to remove it, and then we're going to work on the code in a little bit in another lecture for how do you actually shift everything over. And then of course you've got to decrease the total number of columns, which is the instance variable in that sparse array entries class, by 1 when you remove a single column. So just kind of wrap your mind around that, and I'll do at least one more recording on that to help you out.